Okay, here we go. We are leaving equations and going to inequalities. There will be a couple parts of this unit that will be new and a couple parts that will be review. We start with review today, and that is solving a linear inequality like negative 2x minus 7 is less than 9. And you all know that we add 7 to both sides to get negative 2x is less than 16. Now what? We divide by negative 2. And when you divide by negative 2, you switch the sign. So if you multiply or divide both sides by a negative, switch the sign. Or multiply by a negative. So if you're ever confused about that, negative 3 is less than 4. Would everybody agree? Watch what happens when you multiply both sides by a negative. You get 3 and negative 4. How would you compare 3 and negative 4? You have to switch the sign, right? So you can convince yourself of what to do. It should make sense. So what's the solution? As a graph, we would plot negative 8, open or close circle, arrow to the right. Notice that the answer in interval notation, negative 8 to infinity, with parentheses on both the negative 8 and the infinity. For the test, I will ask for the answer to be an interval notation. The graph sometimes helps you express it that way. Are we good?
8 and infinity are like the same.
Yeah. Same but not. Yeah. Let us look at compound inequalities. Compound means more than one. In this situation, you will have a conjunction, meaning inequalities that come together. Here's how I set up an inequality of this sort. I set up one inequality in the red, and I set up one inequality of the blue. So make sure that the inside, the 3x and minus 7, it applies to both of the outside pieces. Don't break it up. Apply it to both the outside pieces. I will add 7 to both sides. Get negative 2 is less than 3x. Divide by 3. I'm dividing a negative, so do I switch the sign?
No.
But I'm dividing a negative. But you're not dividing by a negative, right? Good. You guys are smart. And you've caught on to my tricks of misleading you, haven't you?
It took me a while.
And we have x is less than or equal to 6 as well. So, as we plot these, negative 2/3, I will go further to the left, and 6 will go further to the right. Open or close circle on negative 2/3. Arrow to the left or right.
To the right.
And x less than or equal to 6.
To the left.
Close circle, arrow to the left. And so notice that the interval notation will be negative 2/3 with a parenthesis and then 6 with a bracket.
So they don't actually join together.
What?
How do you know? Why don't they like connect? Yeah.
Okay, so first of all, your question, which way the arrow goes. Is that correct? So we have to consider the statement. This is saying that x is greater than negative 2/3 as you read it from the variable on. So I'm reading it now from right to left. X is greater than negative 2/3. So which numbers are greater than negative 2/3? The numbers over there. Don't always make it just about looking at the sign. Understand the statement. This is saying numbers that are less than 6. Which numbers are less than 6? The numbers over here.
And then when we write it, like, do we have to rewrite it as 1 or is it fine?
No. Again, I will ask you to write the answer in interval notation. That way we avoid any confusion regarding the inequalities. For the next one, we will end up with a disjunction. Notice as I divide both sides by negative 4, what do I have to do? So x greater than negative 2. It has an or symbol. And then for the next one, we add 3 to both sides, and we get x less than negative 5. Let's talk about where people make mistakes in this situation. Which number do I put here? Do you understand why some people might put -2? Because that's a mistake I make from time to time. Because I moved too quickly, which, by the way, most people had extra time on the test this past day, so it's a great opportunity to go back and check those answers and take your time. Open or close circles. It says x is less than -5. So does the arrow go to the right or to the left? X is greater than -2. So let's just understand what the statement originally is saying. It needs to satisfy one or the other. So is -6 part of one of the solution sets? Yes. Is 0 or is a -3 part of one of the solution sets? No. Is 0 part of one of the solution sets? Is there any number that is part of both? No. See, it just has to be part of one or the other. So the way we express that is from -infinity to -5, and then we write that union symbol in the middle. We introduced that a little bit earlier. Here's where it comes up. We join those two together, the combined set of -infinity, -5, and -2 to infinity. Did have a student once upon a time who asked if it's really necessary to put the union symbol there because it's a lot of extra work. I'm going to let you meditate on that a while, decide if it's really that much work. Okay. So. Let us get to our absolute values. This is where we start to make some mistakes, right? So we have the absolute value of x is less than a constant. So for example, as you read this, we would read it as less than. That's a little trick that I use to try to anticipate what type of inequality it will become. And means conjunction, or means disjunction. So I'll show you the example and it'll work for you right here. Letter B, if you were to solve this absolute value inequality, what would you do first? So you subtract that 2 and you get the absolute value of 3 minus x less than or equal to 5. So as we read this left to right, we read it as less than. That means that these arrows are going to come together. We know that ahead of time. That way you can check your work and make sure you don't make a mistake. See what I'm trying to show you? So let's set this up. The first inequality is 3 minus x is less than or equal to 5. The way we get rid of absolute value symbols is we set two equations or inequalities. Does anybody know what the second inequality will be? -5. When we switch the sign, we then, or switch it to negative, then we then switch the sign. We solve both, and hopefully our answer should be a conjunction. Subtract 3, -x less than or equal to 2. Divide by a -x greater than or equal to -2. Subtract 3, -x greater than or equal to -8. Divide by a -x less than or equal to 8. Open or close circles. Notice how it says x is greater than -2 and x is less than 8. That would tell me that they're coming together. And that matches with what I thought originally, right? So that's a way for us to check our work, because we all know we can make mistakes on these. Let's consider another situation. Suppose you see an absolute value and then what I refer to as a great or than sign. Greater instead of greater, greater. My little play on words. The English teachers don't like me. So. That tells me it's going to be a disjunction. Okay? So this is a conjunction, and this is a disjunction. So as you look at letter A, what would we do first? So the absolute value of 2x minus 3, greater or than 30. So because I see a greater or than sign, that tells me it will be a disjunction. It will go apart. You go ahead and see if you can solve the problem the rest of the way through. Give your final answer in interval notation. I divide both sides by 2. So, folks, did you get this? Did you get these two values? Negative 13.5 and 16.5? Okay, negative 27 over 2 should be negative 13.5.
You want it as decimal?
It's fine however you have it. So my solution would be negative infinity to negative 13.5 or negative 27 over 2, union with 16.5 to infinity.
Oh, we couldn't leave it on you. Really?
So just to be clear, does everybody feel like problem 5A is a problem that they could have success with on the next test?
Yeah.
What if I told you right now that over the past number of years that over a third of the people get that problem incorrect?
Really?
We know the answer. Simple mistakes. It's simple mistakes. We forget to switch the sign. We don't move the 9 over right away. We just take the absolute value signs off right away. There's all sorts of things that we do. So be careful. Take your time. Understand. Prepare. Because this is one that we want to get right, right? Like there's going to be tougher problems than that, so let's get this one right. So we're going to take our time, make sure we're doing a good job. All right. Now we need to tap into your great intelligence. Do you guys agree that absolute value makes things positive? So this is saying that the absolute value of something is greater than a negative. Do you agree that that's true? Is there ever a time where that wouldn't be true? So if you get that set up, you know that the solution is all real numbers. Could an absolute value be less than a negative? Never, right? That would mean that the absolute value is negative, which is impossible. So we would say no solution. Right. You don't like the no solution because you're like, I think I made a mistake. Could an absolute value be less than 0? What kind of numbers are less than 0? So could it ever be less than 0? Could an absolute value be less than or equal to 0? What's the absolute value of 0? 0. So this one would be one solution. Wherever it's equal to 0, that's the one solution that you could come up with. Is an absolute value always greater than 0? Just that one spot where it's equal to 0, right? So this excludes one value wherever it's equal to 0. And our last scenario, absolute value greater than or equal to 0. All real numbers. So we get used to processes and always setting things up. But with inequalities, you have to use a little bit of logic. And so for these next two, let's use some logic here. Don't just follow the steps. Think about it. We divide by 6, and we get the absolute value of x minus 5 is less than or equal to 0. And at that moment, a little light goes off in my head. I'm saying, uh-oh, I've got a 0. If you end up with a 0 or a negative, that could be a problem. So, can an absolute value ever be less than 0? No. Could it be equal to 0? So therefore, we set up one solution. X minus 5 is equal to 0. So X is 5. Now, you don't have to write this, but just to tie in some things that happened last year, you see X is equal to 5. If you were to use that kind of interval notation type piece, remember if it's a single value, you use a roster. Do you remember that? Okay, never mind that. All right, we'll forget that. Third hour remembered it a little bit, but you don't have to write the roster. You could just leave it like that. Okay. It's okay. Don't worry about it. Not that important. And if we use it, I'll bring it back to you at a different time. So I subtract the 18. I get the absolute value of 2x minus 3 is greater than negative 13. Uh-oh, I've got a negative on the other side. Light bulb goes off in my brain. Yeah, an absolute value is always greater than negative. So all reals will work in that situation. All right, we got one last piece. You guys are doing well. A lot to pack into one day, but this is where we're at because we went over the test. We did day makers. Our last piece. What is different about this? It's x squared. Here's what happens is when you get to inequalities that are not linear, meaning they're not x to the first power anymore, you need to get rid of what you thought about in the past in terms of solving. The same rules don't apply anymore, okay? All those little adding, subtracting, multiplying, dividing, it's different. And you got two ways to solve it. Your first one is by making a table. Number line. And then we have our other way to do it, which is to make a graph. Number line. Graph.
I believe I thought it was a process and I was like, what does that say?
Okay, so this is an inequality, one variable, and it's second degree. As soon as I see second degree, I'm like, uh-oh, got to be careful. So here's what I do. As you guys know, I take this 15 and I subtract it over. Anybody want to guess what I do after that? I do factor. Thank you. Are we all on the same page right now? So let me show you what not to do. X plus 5 is greater than 0. X minus 3 is greater than 0. So x is greater than negative 5, and x is greater than 3. No. Doesn't work like that. Remember, the zero product property only works if it's equal to 0. Is this equal to 0? No. So here's what we do. We make a number line. And it's very simple process. Anybody want to guess what two numbers we put on the number line? Negative 5 and positive 3. Way to go. Because those are the values that give us 0. We want to see what values give us positive numbers and what values give us negative numbers. So, Marissa, would you please give me a number to the left of negative 5? Awesome. She chose negative 7. So, I plug in negative 7 to here, and I'm going to see what I get. Negative 7 plus 5. Is that positive or negative? Negative 7 minus 3. And a negative times a negative is a positive. So anything you plug in back there will give you a positive result. Ella, what's the number between negative 5 and 3 you'd like to plug in? 2. 2 plus 5? Positive. 2 minus 3? Negative. And a positive times a negative is a negative. If we would have picked negative 4, what's negative 4 plus 5? Positive. And negative 4 minus 3 is negative. It would have worked either way. Thank you for bringing that up. All right, Trey, a number to the right of 3. 32, thank you. 32 plus 5? Positive. 32 minus 3? Positive. And a positive times a positive is? A positive. That helps us. Are we wondering where it's positive or are we wondering where it's negative? Why? Because we're wondering where it's greater than 0, so we're wondering where it's positive. It's positive here and it's positive there. Because there's no equal sign. See that? So therefore my solution is from negative infinity to negative 5, union 3 to infinity. Now my good friend Michaela during third hour, she saw that and she's like, please show me a shorter way. Anybody else want to see a shorter? Ella wants to see a shorter way. Everybody give Ella an air high five. There you go. All right, thank you. All right, thank you, Ella. Ella, are you ready for the shorter way?
Yeah.
I make a graph. No. Trust me. It's easy, folks. Trust me. Trust me. I plot negative 5 and 3. And all I do is I look at this guy right here. What shape does that make? A parabola. A parabola is right side up or a parabola is upside down. Which one? Right side up because it's a positive x squared, right? So I'm going to draw my parabola. It's going to go through that negative 5 and that positive 3. If you look at the parabola, what do you think it means for a parabola to be greater than 0? What do you think it means for a parabola to be greater than 0? The parts that are above the x-axis. So here the graph is positive because it's above the x-axis. Here the graph is negative because it's below. Here the graph is positive because it's above. So we're going to answer this by saying, where is the graph positive? Because it says, where is it greater than 0? So that would be from negative infinity to negative 5, union with positive 3 to infinity.
Do you mean negative 3?
I kind of attached a little bit further there. I got a 3. Should I just do it again? Just take that guy and we'll just go 3. All right, I'll give you your worksheet.